Okay, we're about to dive into a physics experiment that honestly sounds like it was pulled straight from a sci-fi movie, but it's real, and it could completely change how we see the universe. We're heading deep into the weird and truly wonderful world of quantum mechanics. This quote from one of the researchers, Dr. Sean Hodgman, really just nails it. It gets right to the heart of this whole thing. I mean, just think about that. A particle can be in two places at the exact same time. It's a completely mind-bending idea. But it's not a magic trick. It's a fundamental and, yeah, deeply weird rule of how our universe actually operates. And here it is, the big breakthrough from the Australian National University. For the very first time, scientists have actually watched pairs of atoms pull off this incredible quantum feat. Now, this is a massive, massive step forward. And to really get why it's such a huge deal, we need to look at just how hard this was to achieve. So let's break it down. What did the team at ANU actually see? What did they accomplish? Well, it wasn't just about spotting some strange phenomenon. It was about proving a prediction that has been just out of reach for physicists for more than 100 years. You know, the idea itself isn't brand new. The theory of quantum mechanics predicted over a century ago that matter should be able to do this. But, and this is a big but, there's a huge difference between a prediction on a chalkboard and actually proving it works in a real-world lab. And that's really the crucial point here. As the lead researcher explains, this is an incredibly difficult thing to pull off. I mean, lots of brilliant people have tried this before, and every single one of them has come up short. So, what was different this time? Well, the secret was in what they chose to look at. And this brings us to what makes this experiment a true game changer. It's a huge leap forward, because they didn't just use any old particle. Nope, they used something with mass, something tangible. Okay, check this out. This is the key difference. Before, experiments like this used photons, particles of light. They have no mass, they're super hard to control, and gravity pretty much ignores them. But this experiment used helium atoms. These are particles of actual matter. They have mass, you can cool them down and hold them in place, and, this is the most important part, they're affected by gravity. That one little fact right there, it opens up a whole new universe of possibilities. So why is it such a monumental deal to see this quantum weirdness with a particle that has mass, like an atom? Well, because it might just help us build a bridge across the single biggest gap in all of modern physics. See, for almost 100 years, physics has been playing with two different sets of rules that just don't get along. You've got quantum mechanics, which is amazing at describing the bizarre world of tiny, tiny particles. And then you have Einstein's general relativity, which perfectly explains the huge cosmic scale of stars, galaxies, and gravity. The problem? The two theories are totally incompatible. They speak different languages. Finding a way to unite them into one theory of everything is pretty much the holy grail of physics. And this is exactly why this experiment is such a huge achievement. Let's just walk through it. First, they finally proved a century-old prediction using actual matter. Second, they did it with massive particles for the first time ever. And that gives scientists an incredible new tool, a way to finally test how quantum effects and gravity actually interact with each other. It's a small but absolutely crucial step towards that ultimate prize, a unified theory of everything. So, what's next? You have to understand, this experiment isn't just an endpoint. It's a brand new beginning. Think of it like they just found a key that unlocked a door to a whole new room of cosmic questions we've only ever dreamed of asking. This is the big one. This is the million-dollar question. How do these two different rulebooks for the universe actually talk to each other? By being able to play with quantum atoms inside a gravitational field, scientists can now start to poke and prod at that deep mystery right in the lab for the very first time. Which all leads to this, the ultimate question. Is that grand unifying theory that Einstein searched for his whole life actually something we can reach? Or is it just a beautiful idea? Well, thanks to a couple of helium atoms being in two places at once, we might be closer than ever to finally getting an answer.